Hello, in this video, we are going to talk about character strings. You have probably heard me saying the word string quite a bit throughout the class, and you may have been a little confused. A string is really just a word, it's something enclosed in double quotes. We are going to talk about how we can store strings in character arrays. So, up until this point, we are pretty familiar with the string character, the char data type, or the char data type, however you want to pronounce it. We know what that it is, but we have not really learned about words. To assign a single character to a char variable, the character is enclosed within a pair of single quotes marks. We are familiar with this. We have learned all about this. In this example, plus sign equals plus inside single quotes. The important thing there is the single quotes. You have also learned about that there is a distinction made between single quotes and double quotes. So if you put plus sign variable and you assign it something in double quotes and plus sign is of type char, that's not going to work because you can only assign single characters to the char data type. A string constant or a string literal is a sequence of characters or symbols between a pair of double quotes. So now double quotes are going to come new play. Anything between these double quotes is interpreted by the compiler as a string. And so really it can be alphanumeric character, it can be special characters that they usually make up words. You can kind of think of it as a text. You can have species, but anything in double quotes is a string literal. Every time you have displayed a message using the printf function, we have defined the message as a string constant. Remember the printf, the first argument we put some text inside there, and we have some format specifier. This is a string constant. The you also hear the term string literal. It's the same thing. So we say printf. This is a string. Everything in between that those double quotes is a string constant, and we can put it on one or two lines. You also notice that you can have print statement that have escape sequences backslash n. Now this third one's pretty cool, which I will explain in a second. But the main point is you have to understand the difference between single quotes and double quotes and what's inside there. With the double quotes, you have strings. With the single quotes, you have characters. There are two types of constant. For this third example, this printf, where we have the 4 and then we have a backslash, then a single quote. If you want to actually display a single quote as output, you have to escape it. And you can escape special characters by using the backslash. So in the third example, it's actually going to print out 4 double quote you write and then another double quote. So the compiler interpret an explicit double quote without preceding backslash as a string delimiter. Every other time you use a double quote, it's beginning and ending of a string. But what if you wanted to display it? Then you have to just put the backslash in front of it. And it will tell the compiler, hey, this is not actually ending the string. choose the escape sequence if you want to do the backslash as well, because the backslash is an escape sequence. So when you see the backslash, you are actually displaying that backslash in a printf function. If you see it anywhere else, you are assigning the backslash to a variable or however it's used, but a backslash itself followed by another backslash will escape the backslash string. And again, a backslash and a string always signals the start of an escape sequence. So one by itself is not going to display. These are special characters. So when you are in double quotes, you may see the backslashes to escape special characters, and even the backslash itself. Here is how a string is in memory. A string in memory is just a single character is represented by a bit there here. And so if you have a string called this is a string, you are going to see it where the space has something in memory. And also you should notice at the end that backslash 0. That's the null terminator, which you see everything that's in memory. Even the backslash n, which represent a new lines is in memory, and then for you write, you will notice the quote is in memory, but the backslash is not, because the backslash is delimiting the quote, it's escaping the quote. So this is how it looks in memory. You should notice that the string in memory always has at least one more byte for that backslash 0, which is the null character. Also looks like the diagram on the bottom is incorrect. You will notice the U is not shown here. So after the quotation double quote, you don't see the U there. There, the U should be uh, there somewhere, and it kind of applies. It's there somewhere. They are really just showing it. These are the ASCII values underneath, and so then it's just showing, not showing it, but you would be right before the right. And that's what I want to talk about is this null character. It's a special character with the code value 0. It's added to the end of each string so that the compiler knows where it ends, and also when you run it, this character is known as the null character. And you don't just put a 0 in it, you can put a backslash 0. And that's what was in this previous slide at the very end, and it could be anywhere actually in memory. And depending on where it is in memory, a function is going to go and look until it sees that backslash 0, and it may display it or may manipulate it if you are using different string functions. It's very important that null character, a string is always terminated by a null character. So the length of a string is always 1 greater than the number of characters in the string. This is going to become very important when we use character arrays, and when we specify the size of the array size is going also always going to have to be one more than how many characters you want to store. Because of this null character, we also have a concept of null that I have not really talked about in too much detail. It usually comes into play when we talk about pointers, but do not confuse the null character with the null keyword. So there's a null keyword in one of the include headers that you can use, and this is a symbol that represent a memory address that does not reference anything. So you use it when you use pointers. A null character is just a string terminator. We'll talk more about null when we talk about pointers, but make sure you understand the distinction between null character and the null keyword. You can add a backslash 0 character to the end of a string explicitly, and this will create two strings, and I will show you how to do this when we talk about defining character arrays. Now, here is an example with the null terminator. We have a printf here and we say the character and then the backslash 0 which terminates a string. So what's going to happen is if you compile and run this program, the output that you are going to get is there's going to be it's going to be ended and only the first part of the string is going to be displayed. There is going to be no more output because print thinks that it's the end of the string. So it just print out the character. Output is going to end after those first two words because the function stops outputting once it reaches the null character. So the second backslash 0 at the end of the string, so even though you don't see a backslash 0 here right before the ending double quote, right after string dot, there is still one there, but you don't ever, it's never get reached. So there is an implicit null terminator at the end of the string and the printf, so it knows where to end, and if you add another one, it's only going to display up to that first one. So the first null terminator that's found in the character series always marks the end of the string. So understand these null character. This was just a quick overview to describe what a string is and understand that string are in double quotes. And I also want to describe the null character in the next strings more. And it tend to use the term string and character strings interchangeably, but really a character string is the char array that we are going to talk about. It's very important concept. We are going to be able to now utilize words and text in our program to do all sorts of things. Now C itself does not have any data type that represents a string. There is nothing there. Many languages support either an object or a data type of type string. Now, because there is no data type C in string, you can't use any of the operators on the string. So what we will end up doing is we end up using the standard library, and there is all sorts of string functions that we are going to talk about. We have three lectures dedicated to the various strings function that you can employ, and this will help us manipulate the strings, get information about the strings, but you cannot utilize operators on strings on no pushing or minusing strings, plusing or minusing, nothing like that. Strings in C are stored in an array of type char. We know what an array is. We know what a type char is. A type char is a single character. An array, you can just store multiple elements in the inside of a character array. Because a string is many characters, so characters of a string are stored in adjacent memory cells, one character per cell. You can access it just like you access an array as well, but how you would actually declare a string and see is you would simply use the char type and then the brackets to indicate the size just like a normal array. If you were to create it or a different type, char and then whatever your name is and then the size of the character array inside the square brackets, that's how you can declare a string in C. Now, when you do declare the string in C like this, there is no actual data associated with it. You are just specifying the size. That's the simplest way. So the variable can accommodate a string that contains up to 19 characters. Remember this null character. If you say that your string size is going to be 20, that means only 19 characters can actually be stored because you have that one extra character for the null. Keep that in mind. Declaring a character array is 20 means 19 characters can be stored there. When you specify the dimension of an array that you intend to use for a string, to store a string, it must be at least one greater than the number of characters in the string that you want to store. The compiler will automatically add the null terminator the end of every string constant. So what you should really do is when you create these character strings, you should be initializing them. So you can initialize a string variable just like you can initialize an array. You put each character inside of these brackets. So this looks very similar to if you were to initialize elements in an integer array. But if you say char word and then inside the squiggly brackets you put in each single character, that would create a character array. So it's the same as any other array initialization. In the absence of putting the size, the C compiler automatically computes the number of elements in the array and then adds one for the null terminator. So it's based on the number of initializers you have in between the brackets, curly braces. This statement is going to reserve space and memory for exactly 7 characters. Hello, exclamation point, and then the null terminator. And this little program on the right shows you that automatically and adding that null terminator. Now it's be really a pain in the butt if you always had to initialize your character arrays with the single quotes followed by commas. So what you can do is even shorthand notation is you can just put double quotes around that. So you can either specify the string explicitly like in that first example, and then you would have to actually use a string function just to apply data to it. Or you can let the compiler do it for you. The problem with doing it explicitly is you always have to remember to add that extra character for the null. So what you should really do is you should be letting the compiler figure it out for you. So don't put any number inside those brackets for the size, because if the size specified is too small, the compiler cannot fit the terminating null character at the end of the array, and it does not put one there. And it's not going to tell you that it did not put one there. So you are going to have a bug in your program. You are not even going to know it. Best practice is when you are using a string literal and you are initializing a string to just let the compiler figure out the size for you. Make it a larger size or something and then just put it in there and it will figure out the size for you. So do not specify the size, let the compiler figure it out. This way you can be sure that it's going to be correct. Just leave those bracket as empty bracket and assign it with the assignment operator, and then inside double quotes you can just put it. You don't even need the square brackets. This is the best practice. We'll go through an example. You can also initialize just part of an array of elements of type char with a string. So if you actually created a size that was really large and you only assign a couple characters, that's fine as well too. You are only initializing some of the characters. All the other characters are just going to be empty. So what will happen here is the compiler will initialize the first 5 elements str0 to str4, all those characters of string constant, and then string 5 will contain that null character. Space is still going to be allocated for all 4 elements in the array, but only 5 of those are going to be used for plus the null character. So again, your best practice, don't actually specify a number inside the size, just assign it a string literal with a using double quotes. That's what you are going to end up seeing. Now, if you didn't initialize and you just created the character array with this size, how do you put date in it? Well, because it's array, you can just assign data. We know that it if we had an integer array, we can't just assign an integer array the number 5. It does not make sense. You have to specify the actual elements. You have to specify indices. You cannot do something like declare as a character array with 100 characters and then say s equals hello. That is not going to work, because again s is an array. Even though it's a string inside double quotes, it's still an array in memory. So if you are performing an assignment operation, you cannot assign one array of character to another array of characters like the above. If you want to assign data to a character array after you have declared it and after you have initialized it, you have to use a special function called Str Copy. And we are going to talk about that in another lecture. So up until this point, when you create your string, they are going to be string literals. They are going to be inside double quotes and they are never going to modify them. So this is perfectly valid as well. You could actually just access these characters or each element in the array by the index and specify each character. So index 0, index 1, and then put a single character into single quotes. You could assign it that way, but imagine if you had a string that was 100 bytes. This is going to take a lot of lines of code, so you don't want to do that. What you are going to want to do is initialize it when you declare it with no size and then specify if you ever want to modify it, you str copy. As far as displaying a string as output, we are still going to use that printf function. When you want to refer to a string anywhere in your program, you just use the array name by itself. You don't have to specify indices, because indices inside the array is going to be specify single character. If you want the entire string, you just use the array name. So if you are using the printf function to display output, you would just do the following inside the double quotes. You would use a percent s as your format specifier and then just the name of the character array. So you don't treat it like other arrays. When you want to access it, just the name, no real indices or brackets, and the percent as format specifier is for outputting a null terminated string. Remember, before we used %d for integer, you can use %c for characters. For strings, you use %s and those are character arrays. It expects some null terminated string. So however you initialize the string, if you did it with no size and null terminators are automatically added, or if you created it with a specific size and you added it, or if you added it explicitly, it does not matter. It just has to be null terminated. The printf function assumes one encounters the %s format specifier, that the corresponding argument is a character string that is terminated by a null character. That's what it expects. So it has to be that way. To input a string, we know how to input other sets of data via the keyboard using scanf. We are going to do the same thing for inputting strings. We are going to use a scanf function. With the scanf function, it's going to be the same way, except you are going to use a different format specifier. So for strings, you are going to use a % as an input. And that's used for inputting a string. The other thing to notice here is there is no ampersand for the variable name because it's a character. Remember, we mentioned you only have to provide the ampersand, the address of operator on strings. The reason being is when we talk about pointers, it will be more clear. But char input, even though it's a character array, it's a pointer, and scanf as its second argument take a pointer. And so that's why you don't have to do it when you declare integers and doubles. Those are not pointer. And so if you want to read input from the keyboard using scanf, the second argument expects a pointer. You have to pass in an address. Now, with the scanf, you do a string. Scanf is only going to read up until a space. So if you do scanf and you type in just, it's not going to read the rest of the string. So there is other function that you can use to read the entire string. Some of the examples we are going to use will probably do that. You can do things like fgets, which is another way to read input from the keyboard. And that will read the entire string regardless of spaces. But there's another one, I think it's called get underscore s for C11. But we will talk about that more, but that's just one thing to remember. When you are reading input for strings, it's only going to read all the way up until the space. How about testing if two strings are equal? Well, up until this point, we have tested all variables to see if they are real equal. We just use equals, but with a string, there is not going to work. The equality operator, remember we said that strings are character arrays, so you can't use operators on them. And the equality operator can only be applied to ints and doubles or floats or characters. It does not work on structures or arrays. You can't compare two arrays. So it's not going to work with the strings. If you want to determine if two strings are equal, you have to explicitly compare the two character strings character by character. So you would have to look at each element in the array, index by index. However, that's really a big problem because that would be really tedious. So we are going to talk about how you can do it very easily using a str compare function from the standard library. But you can not use the equals, remember that. And again, just a reminder, I have said it a couple times. I want to say it again. The string constant x inside double quotes is not the same as the character constant x inside single quotes. X inside single quote is a basic type. It's just a char, or X inside double quotes is a drive type. It's an array of type char. X inside double quote easily consists of two characters, the X and the null terminator. The null character, or keep that in mind. Okay. Here's an example of how we can create strings, either declaring them with a size or initializing them on the same line. Now, this is best practice. If you are going to use string literal, that I would do is I would do what it says right here. Create the character array, do not specify a size. And then to the right of the assignment operator have double quotes. The compiler will automatically create the right string and add a null terminator to it. If you specify a size and then you don't have enough characters, it's not going to store it. So just create character string literals by using the char data type, the name of the variable, and then empty brackets. This program is going to, I think, count the characters in an array. So it's essentially going to get the length of the string. What we are doing here is we are creating a variable named count into character arrays. And with two different strings, to be or not to be, and then comma, that is the question. Char str1 is going to have an alternator to after b, and str is going to have an alternative after question. So we have a loop here that's going to go through the first array from count equals 0 all the way until we see a null terminator. And we can use the not equals in this case because we are comparing a character. Null terminator as a character, it's perfectly fine to compare characters. So our while loop is going to go all the way until we see a null terminator. Once we see a null terminator, we are going to jump out. Count is going to be equal to the number of characters in that string. So it's the length of that string. We do it for both strings, and we are going to notice that basically both strings will have the correct length because we are just going through each one to be or not to be. It's going to be something like 18 characters. Now you never going to really need to do anything like this because we have a nice helper function with str length to find length of strings. But hello, we know that a string literals or a string constant is inside double quotes. But what about the variable itself? How can you make sure that the variable can never change that value? This is referred to as a constant. So constant in string is sometimes necessary in your program where you do not want your values of your variables to ever change. So for example, if we are creating a circumference of some calculation, we would do 3.14159 times diameter. 3.14159 is a constant. It never changes. It represents pi. So it would be really nice if instead of using that magic number, we could use a variable and make sure that that variable never changes. So there are good reasons to use a symbolic constant instead of just typing in the number every time. First off, a name tells you a lot more than a number does equals 0.015 times. House value is much less meaningful than odd equals tax rate times value. So we want to have variable names that represent numbers that never change. If you read through a long program, that meaning of the second version is a lot plainer. It's a lot easier to look at that code and understand that 0.015 represent the tax rate. Suppose you have used a constant in several places and it becomes necessary to change its values. You would have to go and change that value everywhere in the program, as opposed to just changing in one spot where you define that constant. I talked about this earlier uh, when I use the term magic number. That's what this is referred to. Whenever you see a number used in a program, it's not stored in a variable. It's usually best to create that number and put it in a constant, because then if you use it multiple times and that variable changes, all you have to do is change it once. You don't have to change it everywhere you use it. So avoid magic numbers, use constant. One way you can define a constant in C is you can use to define preprocessor directives. So this preprocessor directive lets you define constant, and I actually used it in a couple programs. I'm now trying to help explain it. If you wanted to do a tax rate and it was a constant, you could say define with the pound sign before it. We know it's a preprocessor directive because of the pound sign, and then we would say the name and then the value. When your program is compiled, the value 0.015 is going to be substituted everywhere you have used tax rate, just like a variable, but it's actually not a variable. You cannot assign any other values to that. If it was a variable, you had be able to assign data to it, but not in this case because it's a preprocessor. So the preprocessor directive says you can't assign data, and you specify that with the define. So notice the syntax for this. You have the pound symbol followed by defined keyword, and then after that you have your name. We are not using any assignment operator. We just have our name and then the space and then the value. So to assign a value to that define, all you need is a space. There is no semicolon at the end. It's not a statement. It's a very specific. So what's happening here is there are compiler times substitution happening for these preprocessors. The preprocessor runs before the compiler. Remember, preprocessor is going to run and it's going to see these defined carry routes, and then everywhere it sees a tax rate, it's just going to put in 0.015 for the compiler. Defined statements can appear anywhere in that program. There is no such thing as a local define. Once you have a define, anybody can use it. Now best practice or convention is usually to put the defined statement at the beginning of the program or inside an include file if you want to. Share in more than one source file, but you don't have to do that because it's running at the preprocessor. It does not have any scope. It does not have any local or global. You can just put it anywhere, and anywhere in the program you can see it, even if it's being used before it's defined. Defined statements are also really good because they help make your programs more portable. Sometimes you can use a defined statement and relate it to a particular computer you are running on. When the program is running and it will get that very value, the defined statement can also be used for characters and string constant, not just for numbers. So if you wanted to do something like this perfectly said, you just enclose the single characters inside a single quote. And if you want to actually put in an entire string literal, you just put it in a double quotes, and that's what this oops is doing. Another way you can create constants and C is a more recent mechanism. She90 added basically another way which is providing the constant modifier. You can use the constant keyword to convert a declaration for a variable into a declaration for a constant. And this will allow you never to be able to change that variable. So all you do is you say const and then that name the data type and then the name of the variable, and that this does in this example is going to now make months a symbolic constant for 12. We are not calling it a variable because a variable can change, that's why it's called variable. You have constants or variables, and constant in months is not a variable, does not change. Constant makes months into a read only value. You can display months and use it in calculations. You cannot alter the value of months. So constants are important if you do not want data to change, and also they can replace magic numbers. Const is a newer approach and is more flexible than using define. It lets you declare a type. It also has better control over which parts of a program can use the constant. So you should be using constant whenever you can. But you will see a lot of programs using defined because as it was the first mechanism. And also there is third way you can create a constant, and that's using the enum. Remember, we talked about enums. Enums are a way to create your own type of variable and also have certain data associated with it. You can't change the value of enums. Once you define an enum, it has to have those values. It can have different values, but it still is sort of a way to create a symbolic constant, not complete way, but a sort of a way. Also with constant, you can initialize a character array and declare it as a constant. That's a good way of handling standard messages. So if you say const char message equals the end of the world is high, that will declare the message as a constant and it's protected from ever being modified explicitly within your program. Any attempt to try to modify message by doing a str copy will result in an error message from the compiler. And now you can use this for a standard message that may be displayed as output in various parts of the program. The technique for defining standard messages are particularly useful if they are used in many places, like I mentioned. Prevent accidental modification of such constant in other parts of the program, just like magic numbers. So constant, you want to use them in your program. Two ways to employ them, essentially using the define and using the constant keyword. Please pay attention to this. Arrays are not a variable data type in C. So you can use any of the operators, but you are still going to need to be able to do a lot of things on strings. You are going to be able to manipulate them. You are going to want to get the length. You want to compare them. All sorts of things, probably convert them. So luckily the standard library comes with a bunch of functions that you can use to perform these types of operations. I'm going to first start talking about some of the most common ones, and then we will move into more specific ones in other lectures. So we already know that as character string is a char array terminated by a null character. Character strings are commonly used in C programs. Luckily provides many functions specifically designed to work with the strings. The ones that we are going to discuss are the most common ones that you will use. First, getting the length of a string using the str length function. Copying one character string to another. Remember, I told you earlier that you can't use the assignment operator to assign a string. So what you do is you use str copy or str and copy. Also, combining two character string together, concatenation. There's a str cat and strn cat, and determining if two character strings are equal. Again, the equals operator is not going to work for comparing strings because they are arrays. If you want to compare strings, you have to use special functions provided by the library, str compare and strn compare. First, let's talk about the length. All these functions are defined in a string.header file, string.h. So you have to include that when you call or invoke one of these functions. Getting the length of a string, str length is a function that finds the length of the string. It's pretty straightforward. It's returned as a size t variable. You can pretty much use the size t variable interchangeably with an int. But first, you will have to include that string header file if you want to use str length. And this is how you use it. You basically create a string literal inside the double quotes and you assign it to a character array. You don't specify the size of the character array. The compiler will do that for you and will add the null terminator once you have my string defined with a string constant. You can then call str length and just pass in that character. Pretty nice. It's one of the most often used ones because you often want to get this length of a string. When you do validation checks or anything really, if you want to make sure there is no buffer overflows, you can do that as well. This function does change the string. So the function header does not use constant in declaring the formal parameter string. If you were to go and look at string.h inside user include in your directory, you would see that it's not defined as a constant. Copying strings. Copying strings are either modifying an existing string. Modifying an existing character array that has some data in it, or if it does not have anything in it, you want to put something in there. Since you cannot assign a raise in C, you cannot assign strings either. I mentioned this earlier. Declaring a character and then using the equals assignment operator does not work. So what you have to do is you have to use the str copy function to copy a string to an existing string. It's the equivalent of an operator for strings assignment operator. If we declare two characters arrays, source and destination, all we need to do is say str copy source, and then whatever the source is there, we can put in the string. And the same with the destination, you can also put variables in there as well if you wanted to copy those. But what we are doing here is the first parameter is where you are copying to, the second parameter is the string that you are copying. So source would have this is source inside of it after str copy. Destination or would have this as destination. Inside of it after the str copy call, the str copy function does not check to see whether the source string actually fits in the target string. So what would happen if you had a big string? So in this previous example, what would happen if a destination had 100 characters in it? And instead of having this as destination, it had 100 characters. You tried copying it into source that only had 50 characters. There would be a problem. The destination string would be larger than the source string that you are copying. So if we try to copy str copy into source instead of copying this as source, we put in this is sourced 5 times or 10 times, whatever it is, and 1 over 50. There would be an error. And I will demonstrate that. So a safer way to copying strings is to use STRN copy. You will notice that n can be turned to STRN copy. STRN copy takes a third argument, the maximum number of characters to copy. So here you actually specify how much you want to copy. So if you have a source of 40 and a destination of 12 sizes, you can first do an m set. This is just setting the size of the data inside the destination to null terminator. That way when you add something, it will automatically be there. Don't worry about that. And it's not going to check if how are you doing is larger than source. But if you do a strn copy and you copy in a destination, it's going to copy source and it's only going to copy the first 10 characters. So that third argument should be correspond to the size of the destination. So let's go into code blocks and look at str length and look at copying string to see exactly how this works. So here we have our main, and to get the string length, string is really easy. We are going to create our character array. We know how to create a character array. We don't want to specify the size, but we got to put the name first and then the brackets, and then we can initialize it with whatever we want. Say inside the double quote. Double quote represent string literals. So I can just say my name is Jason. The end result of this is going to be an array of size 17 characters. All of these characters plus the null terminator. The null terminator is the \0. You don't have to put that in there because it automatically gets added by the compiler. That's how we can initialize and create a string in a character array. Then to print it, all we have to do is say printf and say the length is, and then we put the %s as a format specifier to display a string. And then all we do is we say the name of the string. And to not get confused, let's just say my string, and we don't have to use the ampersand like we did previous examples. We can just say my string. If we compile and run this, we also may have to make sure we include the string header. When we compile and run this, we are going to see the length of the string So the length is, and when I didn't call the string length function. So you have to actually call the function if you want to display the length. So you just do something like that. You put the string inside str length. Now, when you run it, you would actually see the length of the string. This has to not be a string, but an actual. So that's how I would display the string. If I want to display the length of the string, I do %d in the call or the function. Now, when I run it, you will notice that it actually prints out 16, which is the length, is 15 length. I do %d in the call the function. Now when I run it, you will notice that it actually print out 16, which is the length. Okay, 16. It's pretty easy function to use str length. If you want to copy strings, you use str compare, and you want to use strn compares to actually specify the bytes. So here we have my name is Jason, and then we create another string. Actually, we'll just keep it that we would not even have to specify. And what we are going to do is we are going to say create another string called temp, and that's going to be equal to str, and compare we are going to pass in what we want to copy to. Just create an empty character array, and we are going to just make it a size 50. And what we are going to do here is we are going to say strn copy. The first parameter is where we want to copy. We are going to say temp. Second parameter is what we want to copy, which is my string. And then we don't want to pass in more than 50 bytes. So we can actually say size of temp to say we don't want to pass in more than 50 bytes, and you probably want to do -1 for the null terminator. So this way, that third parameter is really important because we are never going to have buffer overflows. You should always use strn copy and not str copy, and then here we can just display our string to see if it was copied. We could say temp, change it to a %s, and then we will build this. We should see not the length, we should see the string is something like that, and end it with a semicolon. Now we should compile, we do. So now we run it, we should just see our string that was copied in we. So we see my name is Jason, and that is stored inside of temp because we printed out temp. But always use strn copy, don't use str copy. That will make sure that you don't have buffer overflows. And the third parameter should always be the destination, not the source. The destination, it would be pointless to say copy this entire string, because if this is smaller, you are going to have problem. So always say the size of this, and you see that you can use the size of operator to see how many bytes are inside of character. Let's talk about some more functions. So we know how to get the length. We know how to copy strings. How about concatenating strings? The strcap function takes two strings as arguments, and it copies the second string at the end of the first. The second string is not altered, only thus first it will return the value of its first argument. The address of the first character, the string to which the second string is appended. So return something telling you where you actually have appended it if you ever needed to use that. So here is an example. We create a character string or my string, and it just contains my string with a null terminator. We say enter a string to be concatenated. We read it in, and then we concatenated it. We print out the original string followed by the concatenated string and then the input. So after this, whatever you entered would be put at the end of my string. So if you enter JSON, it would be my space string JSON. That's what my string would be equal to. Because you do a strcat on it, first we print out the string and then we call strcat on it. Input is actually going to be equal to whatever was input, my string followed by whatever was input. We'll go through this example in a second. Now, just like str copy, strcat also has a str and cat. So the combined version becomes the new first string. So just like string concatenation with the strcat, there is a string cat. Strcat has the same problem with the strcat copy. It can have a buffer overflow. It does not actually make sure that the second string will fit in the first array. So, if you don't have enough space in that first array, you can run into buffer overflow problems. So what you want to use a STRN cat, a second argument indicate the maximum number of characters to add. So for example, if you do a STRN cat and two strings bucks on add-on, it's only going to add the first 13 character of add-on to bucks. Depends which come first. If adds on is less than 13, then it will only add until you see the full null terminator. So in this example, we are creating two strings. This is the source, this destination. We are doing a strn cat. We are only copying 15 characters into destination at the end. So whatever the size of destination will be size of destination plus 15, and then we print it out. So let's look at this in code block again. So here, here's our example, and we are going to create two character string array. One size 50, the other size 50. We are going to do two str copies to set them to data. This is the source destination, and then on line 12, we do the strn cat. And destination is going to be what we concatenate to. So the source is going to be what we are going to concatenate, and we are only going to assign 15 characters. So if source was bigger than 15, we would not copy all of them. So when we build this and run it, you are just going to see that it now says this is source file, or it's going to say this is destination followed by this is source. So it says this is destination, this is source. It concatenated that onto the end of destination. So you always want to use strncat for concatenation so you don't have buffer overflows. Let's talk about str compare, which I keep accidentally saying instead of str copy, str compare. So for comparing strings, we have to also use a function. If you want to compare one string to another, you can't use double quals, but only checks for references whether or not you have the same address. So what you need to use it, str compare. This is going to compare the string contents. It does not compare the array. So it can be used to compare a string stored in arrays of different sizes. It does not compare its characters. You can use arguments such as apples and double quotes, but you cannot use character arguments such as a single character. This function does for strings that relational operator do for numbers. So the compare function is going to return a value that tells you whether or not the string is equal, whether it's larger or whether it's less than. If it's equal, it's going to return 0. If it is less than, it's going to return less than 0. If it is 1 is less than str2, and if str2 is less than str1, it's going to return greater than 0. And so what exactly does this mean? Well, let me provide you with an example of how this works. Let's put this in the code blocks and run it. But here we are doing a bunch of str compares, and we are going to tell you what the values are, whether they are less than or greater than, because it's not very clear. So let's take this and look at it in code blocks. So here is our example, and we are comparing a bunch of strings and then just displaying the results of str compare. Whether it's a 0, 1, or whatever, so if you compare two strings A and A, they have to be in double quotes. And what you see here, what we are doing is printing out what we are calling. So we are delimiting the quotes, we are putting the backslash to that we actually print out a quote character, and it does not end the string. But if we compare A and A, this should return 0, because 0 means strings are equal. If we compare A and B, str compare should return less than, because A is less than B. B A should return a greater than 0. But let's go through this. Make sure I don't make any mistake, and we'll actually see it in the output. So when we run this, and this helps you remember what numbers are going to be returned. So when you compare A and you actually get 0. If you compare A and B is less than A. So it's a negative one. Something less than 0, I might have said the opposites. See, even I still get them confused because is greater than B. A is greater than B, negative 1. B is less than A, so you get something greater than 0, which is 1C is greater than A, so you get 1. Just then B was greater than A. And then you are comparing uppercase and lowercase. When you compare uppercase and lowercase, it does the inverse. Z is actually less than lowercase a. So capital is always less than lowercase. If you try to compare apples and apple, it's going to be 1, because apple is less than apples. And that's how the comparisons work. It's important to understand the 0 greater than 1 or less than 1. Again, less than 0 is going to say that the first string is less than the second string. And greater than 0 is going to say the first string is greater than the second string. This function is very easy to use. You don't have to worry about any kind of STRN compare, because it does not matter the size of the arrays that you are comparing. The str compare function compares strings until it finds corresponding characters that differ. So it could be all the way to the end of one of the strings. STRN compare function compare the strings until they differ or until it has compared a number of characters specified by the third argument. So in this case, you don't need to use STRN compare for buffer web overflows. It exists, but you only would use it if you only want to compare certain number of characters. It is used differently than the str copy or the strn copy of the strn cat. The strn compare just says I would want to display so many characters. So it would be useful if you are only looking for a prefix. So if you wanted to search for strings that begin with astro, you could limit the search to the first five character and you would use strn compares this way. So this example you see that we say equals equals 0, you often see an if statement like this when you are using str compare. You see str compare inside of this statement and equals equals 0 to say that it's equals. So strn compare uses the first five characters, compares to the first five characters of astronomy, astro. It's going to say that it would found it. It's going to be equal to 0 and it's going to be say found astronomy. If you do the same thing but comparing it to different string called astounding, it's not going to find it. It's actually going to display. It's going to say that astounding is greater than astro. So it's going to display something greater than 0, which is a 1, and it's not going to display any data. So use str compare when you are comparing strings for all the contents. Use strn compare when you only want to compare prefix to a string. Same type of syntax or strn compare, just that third argument. So we talked a lot about some really important functions that we are going to use, mainly str length, str copy, strn cat, and strn compare. We are going to have a challenge where you have to utilize this function that will get you familiar with it. String functions, searching a string, all these functions are going to be in the string header. There's some string searching function that are particular use where you can find a specific character or a substring. The name of those functions are strchr and strstr. Find a single character or substring inside of a string. We will provide some examples of that. There are also some capabilities for tokenizing a string. You may say, what is tokenizing a string? First, you have to define what a token is. A token is a sequence of characters within a string that's bounded by a delimiter. Delimiter is something that is in the string that you notice that has a special meaning. So a token would be if you had a complete string, this is JSON and it was separated by spaces. One token could be this, another could be JSON. It's a way of taking an entire string and breaking it apart in certain boundaries based on a delimiter. And you want to make sure that your delimiter is not something that is valid in the actual string. So you also use delimiters when you read from files, same type of concept where you break a sentence into words. That's called tokenizing. We are going to use this function called strtalk. I also want to talk about some analyzing strings. There are ton of these many different ones to check whether or not characters are lowercase characters or uppercase characters or alphanumeric or digits. These are mainly done on characters, but characters inside strings, and you can also apply them to entire strings. Now we are getting into some more details about strings, and in In order to understand some of these functions, we have to talk a little bit about pointers. Pointers are huge concept in C. We are going to have an entire section devoted to pointer, probably the next one or the one after. And it's a lot of discussion. It's probably the most confusing topic of the language. I don't want to go over that in detail right now because it's not relevant. I only want to touch on it, just give you a little sneak peek about what a pointer is, so that you can understand some of these functions that we are going to use. That's the only purpose of this. So if you don't fully understand pointers at this point, after this couple slides, do not worry. So the concept of a pointer, again, we are going to discuss in details later. But in order to understand some of these string functions, I want to give a quick peek. C provides a remarkable useful type of variable. It's called a pointer. I have been talking about it. It has to do with the memory and memory allocation. Some languages, if you have programmed before, you are not entirely new to programming. Some languages will automatically manage memory for you. They will allocate memory for you and delete it. Language like Java does this. It's called the garbage collector. A language like C does not do this. So whenever you create memory for using pointers, you have to delete that memory. But what a pointer is, it's very useful. And what it is, it's a variable that store an address. An address, remember, is something in memory. It's usually hexadecimal. The value in the address is in another location in memory. The pointer just points to an address. That address contains a value. And we are actually used addresses in the past with the scanf function. Remember that ampersand symbol that we have used, that's the address of operator. A scanf function as its second parameter would have to take in a variable that you wanted to store the data. That variable, it has to be pointer. And so the scanf function expected a pointer to create an integer by itself. It's not a pointer, but if you get the address of it, it now becomes a pointer. So we are using the ampersand to get the address of a primitive data type. So you are a little familiar with the address concept. Remember, from now with pointers, you create int number. And that's not pointer and it's equal to 25. But if you get the ampersand of it, which is the address of it, you can then assign it to a pointer. A pointer has a special syntax in C. The asterisk represents a pointer. So we declared a variable number with the value 25 and then we declared a pointer using the asterisk number p number, which contains the address of number. And again, the asterisk is used to declare the pointer. That's how you know it's a pointer data type. To get the value of the variable p number, because p number is what? It's pointer. It's pointing to an address in memory. If you just try to look at the value of p number, it's going to give you the address. If you want to get the value of the what the address is pointing to, you have to dereference it. So there is a special syntax that C uses. It's called the asterisk and the name of the variable. That's how you can actually access the memory location that contains the value. So if you want to assign data to that memory location, you have to say star p number. Again, the effect is it access the data stored at the address specified by the pointer. So it becomes very confusing when we talk about pointers because you are not used to this concept. You think a variable has a value, that's it. But a variable can have an address, and the address can then have a value. This slide tries to illustrate what I just mentioned. I found this in a book that I have read. It's a slide that shows you the concept of a pointer in memory and how things work with the address. So I'm kind of reiterating what I just mentioned, but the value of ampersand number is the address where number is located. So if you have two variables, number and p number is a pointer, number is an int. You also, by the way, have to specify the type of the pointer. Even though pointer is an address, you still specify the type or where the address is pointing to. So int star p number is going to be equal the address of number. Number is in memory and it points to an address of 1,000, for example, and it has a value of 25. P number has an address of 105 for that actual P number, but the value of that address is 1000 address. In order to get the value of P number, you would have to dereference the 1000, which will give you 25. The reason I mention all this thing about pointers, because a lot of string functions are going to return pointer. It's not going to really matter that much. It's only important when you want to understand how you are getting a certain character inside of an array. But I did want to briefly mention them. It's okay if the concept does not sink in right now, because we are going to cover it in a ton of detail in a later section. But understand that the string functions now that we are going to use are going to return pointers. And then you are going to maybe use that return to do something useful. In the past, when we use the str copies and str compares, we passed in pointer, but it never returned pointers. We never had to use that pointer. Now that we have to use the pointer, I want to just give a little description of what that means. Pointer is just going to point to an address, and then you can use that address to do parsing or whatever you need to do. So hopefully this did not overwhelm you. Again, don't worry if you don't fully understand it. We'll go through some examples now of analyzing, tokenizing, and searching strings. To search for a string, we mentioned you are going to use the strchr or the strstr. The strchr searches a given string for a single character. The first argument to the function is the string to be searched, which will be the address of a character array. The second argument is the character that you are looking for. We'll provide an example in a second. So the function is going to search the string starting at the beginning and return a pointer to the first position in the string where the character is found. This is why pointer is important now, because we are not returning an entire value. We are returning a pointer to a character inside of a string. And that address represents the index of an array. Essentially, so the address of this position in memory, it's a type character star. And it's described as a pointer to a char, which is really just a single character in memory. To store the value that returned, you must create a variable that can store the address of a character. So you have to create a pointer. If the character is now found, the function returns a special value, which is null. Null means that the pointer does not point to anything. We use null when we talk about pointers. And null is just saying it didn't find anything. So it's not pointing to anything. When it pointing to something, it points to the address of where you find that character, and then you can start parsing from there. Because remember from the earlier lectures, when you have a search character represented as a byte, and if you are parsing a string and you want to see where a particular character start in that string, you return that byte and then you can start looking from there. So strchar, how you use it is this: you say you create a character string. And we initialize it here with a quick brown fox. And we initialize it, we then create a single character and we initialize that with Q. Then we create a pointer because we have to create a pointer because that's what returned it from the str. That's what allows us to see where in that string we found a character. We are going to initialize our pointer to null because right now it's not going to point to anything. Then we are going to call strchar. We are going to pass in our string, which is in the quick brown fox, and we are going to pass in our single character, which is q. What's going to happen is it's going to look inside the quick brown fox, and the first time it finds a q, it's going to return the address of that q. So p got char is really going to be pointing to the fourth index of str because t is sub 0, h is I index 1, E is 2, space is 3, Q is 4. So P got char is going to point to Q in the quick brown fox. And so you can see exactly where that character start in that string. So the first argument to strchar is the address of the first location to be searched, that's the search string. Second argument is the character that is sought, the character that you want to look for, a single character. It expects the second argument to be of type int. So technically strchar, the second argument takes in, but C compiler will automatically convert the chart to an int. It will get the ASCII value essentially. So you could actually define the queue single character. Instead of a single char, you could define it as an int. That's just more of a technicality that I wanted you to know about, but p got char is going to point to the value quick brown fox because it's going to start at q and then it's going to go to the null terminator if you try to print it out. So it's actually going to be quick brown fox when you run this example. This is how you can search for a single character in an entire string. Use strchar, then use the pointer and then display the pointer. And how do you display that pointer? The same way you display the other character, use printf %s. So this is a nice mechanism to search for characters in an entire string. If you want to search for a string inside of a string, which would be substring, you use substr. This is probably the most useful of all searching functions. It searches one string for the occurrence of a substring, and it returns a pointer to the position in the first string where the substring is found. Very similar to strchar, but it searches an entire string. If it did not find any match, it returns null. The first argument is the string that is to be searched just like strchar. Second is the substring. You are looking for another string. So here is an example. It looks very similar to other one, except instead of looking for a single character, we are looking for a word, a string. So we have word, which is equal to dog. And we have text, which is every dog has his day. We create our pointer again because it has to be. This is what the function returns. When we call str, we pass in the text, the string that we want to look at. And then the second argument is the word that we want to look inside that string. So it's going to search for the text, the first occurrence of the string stored in word. The string dog appears at the 7th character in text. If you look at text sub 6 is going to be equal to dog. That's where it starts. So the pointer is going to point to the address of text plus 6 dog, and it's going to start there and then it's going to go to the null terminator. So p found is going to be dog has its day, and also be careful because the search is case sensitive. If you actually provided a capital dog, you are not going to find anything. It's only going to look for the correct case, but this is used to find substrings and strings, very useful because a lot of times in programs you are going to say something this string inside this string because it's almost similar like a grep if you have ever used grep on Linux. I hope this makes sense. Tokenizing a string, a token is a sequence of characters, one of them a string that is bound by a delimiter. We know this. A delimiter can be anything, but it should be something unique to that string. Don't have a delimiter as a because now it's going to find in that string something valid in a word. Make it something unique like a space or a comma. Thus, again is used as a boundary for usually words in a single string. So it breaks a sentence into words. It's called tokenizing. This str talk function is used for tokenizing a string. It requires two arguments: the string to be tokenized, which is the entire string that has the spaces and has the delimiters, and then the string containing all that positive limited characters. You can specify what you want to set as the boundary. So here is an example. We are creating a character array 80. It says hello, how are you? You are Des. My name is Des Jason. We then create a constant string that represents the delimiter, which is the minus the Des. It looks a little different, but it's still the minus the dash. They are both dashes. And then we create our pointer, which is token, because str toke is going to return our each token. So if we call our str toke and we pass in string and we pass in our delimiters, token is going to be equal to the first thing that it finds. So the first time you call str toke, it's going to be equal to hello, how are you? Space, and then it finds the edge with the dash. And if you call for a second time, it's going to print out my name is. If you call it a third time, it's going to print out Jason because it's going through the dashes. So that's why we have a while loop here. We say while the token is not equal to null, print out the token. And then we get the next token by calling strtalk. And we say null as our first parameter and s is our second parameter. And then we display, so it's look at this in code blocks since it will make it more understandable. So let's build this. We just went through this example. I want to show you what the output is. So it's clear what's going on here. So here you will see that it says it print out the first token, which is hello, how are you? Well, the first thing it does is it find the first token, print it out, hello, how are you? My name is this and this, Jason. Now we have hello, how are you? Find the first this, print it out, hello, how are you? My name is then Jason, and now we have hello, how are you? Find the first dash, print it out. My name is find the next token. Then the third one is Jason, but you have to call the token three times to get each token. The first one is going to tokenize on the str. See the next one. See the next one, you can pass in null because you don't want to look again. You just want to get the next token. So you pass null, the second one, and you just pass an S, it will give you the next token of the str already talk. So that's how you can use str talk. It helps a lot with parsing. You can parse something and get certain boundaries and out. Last function I want to talk about are these analyzing string functions. There is a ton of them, so I just provided little tables here. Is lower, is upper. It does exactly what you think it would be do. It tests to see if a character is lowercase or uppercase. We are testing certain character, but they are used inside strings. And so the argument to each of these functions is the character that you want to look for. And then all these functions return a non-zero value of type int if the character is within the set that's being tested. So we are going to pass int characters inside looking for inside words. If we have an uppercase letter inside of a word, it will tell us, and we can use it for parsing individual elements in a character way as well. So the return values will convert to true or false. So you can use them as booleans as well, which is nice. So is lower will return true if a word or character has a lowercase character. Well, here is a nice example I wanted to run through, which will count the number of letters, digits in an entire string. So let's run this because this will be clear. But what you should notice is we are creating a buffer, our input buffer, and then we are creating three integers to count. We are telling the user to input a string of less than so many characters. We then read it in. We are then going to look at that string to see if it contains certain characters. And so we are going to iterate through that string by looking at each index in the array. So here is our example again. Buffer is our character array that's going to store input. We are going to use scanf to populate that. We have to type in our string with no space, it's a single character. We are going to run through it. So throw each element in the buffer and then call the is alpha is digit or is a func definition. If those characters are in there, and then it will increment based on that whether or not that returns. And then it will display out how many letters, digits, and punctuations characters are inside. Let's run this. I'm just going to enter something with a bunch of uppercase, maybe some digits. Then when I hit return, it's going to count every day. Everything. So it says my steering contain 24 letters, 4 digits, and 1 punctuation character. Nice little, neat little program that utilizes those character function but are useful analyzing a string because that's what you are doing. You are analyzing the. Okay. It is very common to convert character case specifically. If you want to make your string all uppercase characters, luckily there is two upper function that convert from lowercase to uppercase and the two lower function that converts from uppercase to lowercase. So lowercase to upper or upper to lower, both functions return either the converted character or the same character for characters that are already in the correct use or not convertible, such as punctuation characters if you can't convert them. So this is how you can convert a string to uppercase. Remember, there are actually utilized on character by character basis. So if you had a buffer that was a character array, you would have to go through each element in the buffer and then do a to upper on that character. So here we are going through each element in our buffer character array and we are passing it to the two upper method, and that's going to return a character. That's an upper case, and we are going to assign it to our buff up by we are going to do that until we hit the null character. So this is a core statement that just has one line. This converts the entire string in a buffer rate uppercase by stepping through the string one character at a time. The loop stops when it reaches the string termination character, the \0. The cast of the type char is there because two upper returns of type int, which is the ASCII value, and it just converts it. And you should do the same thing if you wanted to convert it to lowercase. Very simple to use the case conversion functions. So you can use the function to upper in combination with the str function to find out whether one string occurs in another, ignoring the case. So let's look at this example that does exactly that. Here we have two character arrays, text and substring. Text is size 100, substring is size 40. We ask the user to enter a string to be sized less than 100 characters. We get that we store it in text, and then we return, then we enter the string that they want to find using the str. So then the substring, so they enter using other substring. We then print the first string and then we print the second string. We then convert both the strings to uppercase, and then we can actually say the second string found the first string. So when we call str, it can ignore case. Because remember, one of the limitations of str was that it was case sensitive. And so now we can use str or text and substring because they are all uppercase characters. And again, this is a way to find whether a substring is in an entire string ignoring case. First, we just convert everything to uppercase, and now we are comparing uppercase, and that's what this program does. It's often the case that you will want to convert strings to number. So there's a specific function that start with an A. They are like ATOF, ATOI, ATOL, ATOLL, ATOI very common, converting a string to an int. So ATOF is going to convert a string and it's like ASCII. ASCII TOF, it's going to convert a string to a data type. So an ATOF is an ASCII to a float or double to a float. And you may have certain return values if it's not found or can't not do. So sometimes you can't convert strings to integers, especially if you have a string that just had words. Usually you use this function when you have in the example. If you have a character string that has 98.4 that can be represented as double, so you can do an ATOF on it. If you have a character string of JSON, you can't convert that to a float, an integer. So nothing going to happen. So when you have character string that have number, you can convert them using these ASCII to functions. And this is all included in the standard lib header file. You will also see the opposite for creating integers to a string. You will see things like ITOA, which is an int to ASCII. If you had a number 98 and you want to convert it to a string, you had say ITOA. It's also some newer function. These one are specifically for string to double as opposed to ATOF. And you can use these strtod or strtof or string told, and they reach each just convert to either long double floats or floats doubles. But either one of them is fine. The sky ones are the traditional ones. I think the other STRDODS or STROFS were added in the later standard of C. So here is an example of doing some conversions. It's very, very basic. Here we have a str character. (3.5) space, 2.5 space, 1.26. We have a couple pointers and we are going to throw until we jump out is if we can't convert it. So we say strtod, we pass in our address of our ptr, our pointer, and we pass in our p string, which is in our string 3.5, 2.5. Now you may say, why are you passing in the pstr as opposed to just the str? And you don't have to. But here we want to actually check if there was no conversion. So because we are checking for no conversion, we have to look at both pointers. You can't compare the PTR to the STR because the STR is an array. So we are going to use PSTR to just represent our character array so we can compare, and we compare those two. It means PSTR stored no conversion, and so we are done. We were not able to actually convert that value. Otherwise, if we were able to convert the value, we are just going to print it out. And we are then going to go for the next conversion. PSTAR is going to equal to pointer. So you can run this and you can see that it's going to end up converting everything in the string array to specific values doubles. Doubles values, I usually use ATUI, ATUF, but either one of these will work. These are the conversion functions. Thank you. The first challenge related to character strings. So I hope you guys are getting familiar with the strings. Character arrays, a very important concept with C. This idea of storing these string literals and variables, character arrays, understand that it's an array and how you can access different elements. This challenge is going to be focused on that. We are going to have another challenge after that helps you understand how to use some of these string functions, because we cover a lot of those. But this one really is for you guys to get familiar with this concept of character string and a character array. So the requirement for this assignment are you are going to write a program that tests your understanding of character arrays. So what I want you to do is I want you to write a number of functions. I want you to first write a function that convert the number of characters in a string. It would be similar to the str length, but you are going to actually implement it yourself without using that function. So you cannot use the str length library function, and the function should take a character as a parameter and it should return an int. So you can just have a character array as the parameter. You don't have to worry about pointers at all in constant in this assignment. This is just going to take maybe a parameter constant because it's not going to change. And all you are going to do is you are going to need to iterate through the array. So even though you have a string, you are still can access individual characters because it's an array. So if you can access the individual characters, you can just keep a count and then display it. The function should return an integer, which is the length. The next function I want you to write is I want you to implement the concatenate function, where you can concatenate two strings. Again, I don't want you using any library function. Don't use strcat. This function should take 3 parameters. the result, and then the two characters that you want to concatenate. So those can be constant because you are not going to change those. The result is just because to be the character string that you store in. So pretty simple. Again, you don't have to deal with pointers. You are going to have a couple loops, go through each one of the arrays and assign to the result array. And what you should return for this function is nothing. You don't have to return anything because you are passing in the result array. We could modify this and return a pointer and stuff like that, but we are not going to do that for this assignment. So this is going to manually concatenate two strings. Third function I want you to write is to compare two strings to see if they are equal. Again, I don't want you to use the library function. I want you to understand how these character arrays work. This function should take two constant character arrays as a parameter, and it should return a boolean, either true or false. True if they are equal, false otherwise. So what are you going to have to do? You are going to have to iterate through the arrays and compare each character, and you should probably look for the null terminator for the equal strings, because the null terminator can determine when you want to stop, because you don't have the sizes of these arrays. So you are going to have to look for null terminator to determine when the second string, and you should actually compare the second string to the first. So you have to figure out how to do this, but here's three functions to get you familiar with creating character array and manipulating it or accessing it to determine its length, concatenating it and checking if it's equal. Good luck. Like to go through another challenge. Second challenge of this section mainly has to do with the string functions, getting you familiar with str length and str compare, which are two of the most common function available. Also, I think string copy you are going to use for these. So I want you to write a challenge that's going to reverse the string, and also a challenge for using str compare. So write a program that displays a string in reverse order. You should read input from the keyboard, and you need to use the str length string function because you need to find the size of the string. Once you have the size of the string, you can then start reversing characters. I would also like you to write a program that sorts the string of an array using bubble sort. You will need to use str compare and str copy function to get this to work. If you don't know what a bubble sort is, you are going to have to look it up or do some research. It's really easy sorting algorithm for anything integers, strings, whatever in the case strings. And what it will look like the program if you run it, you will ask the user to input a number of strings. They will say 3. They can input the string 3 times, so the say 0, 1 or 2. So you could have a loop here with scanf. The expected output would be 1, 2, 0 OTZ, and that's all the information I'm going to give you. Pretty basic example. You are going to need to understand the arguments and parameters that go to the str compare, the str copy, and the str length, and what they return. And you don't really have to understand much about pointers for this. Really just the basic. These are the two pretty state assignments, and go and do this assignment. Good luck for this section, and we are moving to another section, debugging, after that.